Welcome to the exploration of a tantalizing possibility in the cosmos. Why there could be a dark mirror universe. Imagine, if you will, a universe that mirrors our own, hidden yet intertwined, where the laws of physics hold sway in forms unfamiliar to us. This isn't mere science fiction, it's a serious hypothesis that many physicists and cosmologists are pondering over. Let's start with the basics. Our universe, vast and mysterious, is composed of everything we can see, touch and measure: planets, stars, galaxies, and all forms of energy and matter. But what if there's more? What if there exists another universe, a shadow realm, where dark matter and dark energy play a starring role? Dark matter, an unseen force, makes up about 27% of the universe. It doesn't emit, absorb, or reflect light, making it completely invisible and detectable only through its gravitational effects. But here's where it gets even more intriguing. What if dark matter is more than just an invisible scaffold? What if it's a hint, a whisper, of a vast dark universe all its own? This brings us to the concept of a dark mirror universe. A parallel cosmos where dark matter isn't just something that fills the gaps, but something that constructs an entire shadow world, governed by its own dark laws of physics. In this mirror universe, there could be dark stars, dark planets, and maybe even dark life, all made up of dark matter. The notion of a mirror universe helps explain several perplexing cosmic mysteries, including why the universe is expanding at an accelerating rate. Could the gravitational pull from this unseen universe be influencing our own? Moreover, it offers tantalizing possibilities for understanding the nature and origins of dark matter and dark energy, two of the most profound mysteries in modern physics. Exploring this dark mirror universe isn't just about satisfying our curiosity. It's about understanding the fundamental components of reality itself, pushing the boundaries of human knowledge and redefining the cosmos in which we live. Stay with us as we delve deeper into this shadowy reflection of our own reality. Could there indeed be a dark mirror universe? Let's find out together. What if I told you that beyond the stars, there could be a mirror to our universe, hidden and dark? This isn't the plot of a science fiction novel, but a possibility that some cosmologists are seriously pondering today. Let's delve into the fascinating concept of a dark mirror universe. Imagine, if you will, a universe that runs parallel to our own yet remains unseen. This hidden cosmos is thought to be composed primarily of dark matter, the elusive substance that does not emit, absorb, or reflect light, making it incredibly difficult to detect with our current technology. Dark matter is estimated to make up about 85% of the total mass of the universe, yet it interacts with our familiar matter only through gravity. But why consider the idea of a dark mirror universe? Beyond the allure of the unknown, this concept stems from attempts to solve some of the most perplexing puzzles in cosmology. For instance, why is gravity weaker than the other fundamental forces? Could there be massive particles out there invisible to us that account for this anomaly? The notion of a dark mirror universe suggests that there might be a complete copy of our own universe's galaxies, stars, and perhaps even life, all made up of dark matter. These shadowy counterparts would be almost entirely imperceptible to us, as our instruments are designed to detect light, not the absence of it. Observationally, the challenge lies in detecting something that is, by its very nature, designed to be undetectable. Scientists have proposed several methods to catch a glimpse of this dark sector. These include observing the effects of dark matter on cosmic microwave background radiation, the afterglow of the Big Bang, or studying gravitational lensing, where gravity bends the path of light from distant galaxies and stars. Imagine a cosmos where a shadowy twin of our own universe exists, out of sight but perhaps not completely out of reach. This enigmatic possibility pushes the boundaries of our understanding and challenges us to look beyond what we can easily see. To understand the dark mirror universe, first grasp what dark matter is. Imagine peering through a telescope hoping to uncover the universe's secrets, only to find that more than 80% of it is missing. Not missing in the literal sense, but invisible, undetectable by conventional means. This is the enigma of dark matter. The story begins in the early 20th century with a Swiss astronomer named Fritz Zwicky. He observed that galaxies in clusters moved as if greatly influenced by substantial amounts of unseen mass. This invisible mass, which he termed dark matter, seemed to exert a gravitational pull, yet it eluded direct detection because it doesn't emit, absorb, or reflect light. Dark matter does not interact with electromagnetic forces. This characteristic renders it invisible and undetectable by traditional optical instruments. However, its presence is inferred from gravitational effects on visible matter, radiation, and the large-scale structure of the universe. For instance, galaxies rotate at such speeds that without the presence of dark matter, they would tear themselves apart. Yet, they hold together, suggesting that dark matter provides the necessary gravitational glue. This leads us into the fascinating hypothesis of a dark mirror universe. If dark matter interacts through gravity but not electromagnetism, could there be entire shadow galaxies, even shadow life made up of dark matter? Just as our universe has planets, stars and galaxies visible through light, the dark mirror universe, if it exists, would be a cosmos parallel to our own, perceptible only through its gravitational effects. The implications of such a universe are profound. It suggests a cosmos where the rules are vastly different from our own, a place where light does not dictate the architecture of matter. Researchers are now piecing together this puzzle using clues from the behavior of galaxies and the cosmic microwave background radiation. So, dark matter remains invisible, yet its gravitational pull could be shaping an entire shadow universe. This hypothesis not only expands our understanding of the cosmos, but challenges our very perceptions of reality itself. Scientists rely on advanced theories and mathematics to explore possibilities that we can't yet see. To grasp the concept of a dark mirror universe, one must dive into the depths of theoretical physics, where ideas like the multiverse theory and mirror matter theory come into play. These theories might sound like something out of a science fiction novel, but they are serious scientific propositions that challenge our understanding of the universe. Let's start with the multiverse theory. This theory suggests that our universe might just be one of many, potentially infinite universes existing simultaneously. Each of these universes could have different physical laws or constants. The idea of a mirror universe arises as a speculative subset of this theory, proposing a universe that is a mirror image of our own, with particles and forces that are opposite to those we know. Now turning to mirror matter theory, which takes this concept a bit further. It postulates the existence of particles that are mirror images of the particles in our universe. These mirror particles interact with each other just as particles in our universe do, but they do not interact directly with normal matter. This could explain why we don't readily see effects of mirror matter, even if it's all around us. Symmetry plays a crucial role in these theories. In physics, symmetry is a fundamental aspect that underlies many physical laws. It refers to a situation where something does not change under a set of transformations. For the universe, this could mean that for every particle that exists, there is a corresponding mirror particle, reflecting a symmetrical property across both universes. These concepts are supported by rigorous mathematical frameworks and have implications that stretch from the cosmic scale down to subatomic particles. They offer potential explanations for phenomena that remain mysterious, such as dark matter and the imbalance between matter and antimatter in our universe. These theories are not just wild guesses, but are grounded in the same scientific principles that explain the universe we know. Across the globe, physicists are not just sitting idle, they are actively hunting for signs of this mirror universe. In the hidden chambers of world-renowned laboratories and beneath the Earth in vast experimental caverns, the quest to understand the cosmos continues. At places like CERN, the European Organization for Nuclear Research, scientists are pioneering experiments that delve into the very fabric of the universe. The Large Hadron Collider, the world's largest and most powerful particle accelerator, collides protons at near the speed of light. These high-energy collisions create a shower of particles, some of which may hold clues to the existence of dark matter and mirror particles. The detectors surrounding the collision point capture these fleeting moments, providing valuable data that could hint at the presence of a mirror universe. Meanwhile, across the Atlantic, researchers at Fermilab are conducting the Fermi National Accelerator Laboratory's muon G2 experiment. This experiment focuses on the behavior of muons, which are particles similar to electrons but with a greater mass. By studying the way muons wobble as they move through a magnetic field, scientists hope to detect anomalies that could suggest interactions with unseen particles, possibly those from a mirror universe. In addition to particle accelerators, astronomers use telescopes to observe the cosmos for indirect signs of dark matter. Observations of how galaxies rotate and how light bends as it passes massive objects in space could provide indirect evidence of dark matter, which in turn could be a component of a mirror universe. Each of these experiments, whether they involve colliding particles or observing distant galaxies, is a piece in the vast puzzle of our universe. Physicists and astronomers alike combine these pieces, hoping to construct a clearer picture of what lies beyond our current understanding. Each experiment brings us closer to potentially uncovering our universe's shadowy twin. The implications of a dark mirror universe extend beyond just scientific curiosity. Imagine uncovering a reality where all the rules of physics as we know them are inverted or altered. This isn't just a scenario for science fiction, it's a possibility that could redefine our entire understanding of the cosmos. Let's delve into the physics first. If the existence of a mirror universe is confirmed, it might provide the answers to some of the most perplexing questions in modern physics. Dark matter, for instance, remains one of the universe's greatest mysteries. If dark matter particles have counterparts in a mirror universe, it could explain why they interact so weakly with our own universe. This could lead to a revolutionary new framework in particle physics, potentially leading to a unified theory that integrates dark matter and the forces governing particles and their interactions. From a cosmological perspective, a mirror universe could imply a vast, possibly infinite series of universes. This multiverse scenario would force us to rethink the Big Bang theory and the evolution of our own universe. How did these universes diverge? What does this say about the fate of our universe? These questions could shift our understanding of time, space, and the ultimate destiny of all that exists. Philosophically, the discovery of a mirror universe poses profound questions about reality and existence. If there are multiple universes, what does that say about the nature of reality? Are there versions of ourselves living different lives? Such revelations could alter our perceptions of identity, destiny, and free will. The psychological and cultural impact of such knowledge could be as monumental as the scientific revelations. In essence, finding a mirror universe is not just about discovering new celestial bodies or particles. It's about uncovering a whole new layer of reality that exists alongside our own, invisible yet influential. This could lead to technological advancements as we learn to interact with or harness the properties of this parallel universe. Finding a mirror universe could fundamentally change our place in the cosmos. It invites us to look beyond our universe, to imagine and explore the profound mysteries lying in the shadows of our existence. However, not all are convinced of the dark mirror universe theory. The idea of a dark mirror universe, tantalizing as it may be, faces significant skepticism from various quarters of the scientific community. Critics argue that the theory, while rich in imaginative detail, is mired in speculative physics. It leans heavily on assumptions that are not only unproven, but in many cases currently unprovable. One of the chief criticisms is the sheer difficulty in testing these theories. The dark mirror universe is predicated on the existence of dark matter, a substance that, despite its gravitational influence on galaxies, has evaded direct detection. This elusive nature of dark matter makes the dark mirror universe theory particularly challenging to verify. Scientists are left to rely on indirect evidence, which can often be interpreted in multiple ways. Moreover, the theory also hinges on the behavior of particles and forces that we have yet to understand fully. The hypothetical particles that would bridge our universe with this dark mirror counterpart, often referred to as portal particles, remain purely theoretical. Without concrete evidence of these particles, the foundation of the dark mirror universe theory remains on shaky ground. Another point of contention is the potential for confirmation bias. Enthusiasts of the theory might be seeing what they want to see in the cosmic shadows, interpreting anomalies as evidence of a mirror universe when they might merely be quirks of known physics or observational errors. Additionally, some physicists argue that introducing a dark mirror universe complicates our understanding of the cosmos without necessarily adding clarity. They caution against veering too far into the realm of theoretical excess, where elegant equations might create beautiful models that, unfortunately, do not correspond with reality. Despite these criticisms, the discussion around a dark mirror universe is invaluable. It pushes the boundaries of what we know and understand about our universe, challenging physicists to rethink the fundamental principles of matter, energy, and gravity. Science, after all, advances by questioning and challenging what we think we know. What does the future hold for the quest to uncover the dark mirror universe? As we stand on the brink of new discoveries, the tools and technologies at our disposal are evolving at an unprecedented rate. The next generation of telescopes, both ground-based and orbiting in the cosmos, promise to peer deeper into the dark corners of our universe than ever before. These technological marvels are poised to either catch a glimpse of the elusive dark mirror universe or provide the data necessary to challenge its very existence. Consider the advancements in quantum computing and sensor technology. These are not just tools for the tech-savvy. They are the beacons that could light our way to understanding the cosmos's most cryptic phenomena. Quantum sensors, for example, are expected to dramatically increase the precision of measurements at astronomical scales, potentially revealing interactions that hint at a dark mirror universe. Upcoming missions, like those planned by various international space agencies, aim to map the cosmic microwave background radiation with greater accuracy. This could help scientists detect anomalies suggestive of dark matter and perhaps even the effects of a parallel universe. Each mission carries with it a payload of possibilities, a chance to answer age-old questions that have teased the minds of the curious and the scholarly alike. As these technologies advance and more missions take to the skies, the scope of cosmological research will expand. The data gathered will not only feed the hungry minds of theoretical physicists, but also trickle down to enhance other fields of scientific inquiry. The implications of discovering a dark mirror universe, or definitively proving its non-existence, are profound, potentially reshaping our understanding of physics, reality, and our place in the cosmos. Whether or not we find it, the journey to uncover the mysteries of our universe continues to inspire and challenge us. The path ahead is lined with innovation and the relentless pursuit of knowledge. As we harness these new technologies and launch into future missions, our vision of the universe might change, but our quest for understanding remains constant. In the pursuit of the dark mirror universe, every question answered leads to new mysteries, and every technological leap broadens the horizons of possibility. The journey is as monumental as the destination.